a couple more examples of being able to solve differential equations by separable methods. We have this differential dy dx equals 4x cubed divided by 5y. All right. Now there's no initial value for this one. So all we're going to do is we're going to start by multiplying both sides by 5y. So we get dy times 5y over dx is going to be equal to 4x cubed. And then we can also multiply by dx. All right. So ultimately, we end up with 5y dy is going to be equal to 4x cubed dx. Right? And it asks us to be able to solve this. Okay, so now we've got all the y's and x's to one side. And so now we can integrate. Antiderivative of 5y is going to be 5 halves y squared. Antiderivative of 4x cubed is going to be 4x to the fourth over 4. And then we have our constant of integration. It asks us to be able to solve as a function of the independent variable. All right, so what I'm going to do is I'm going to multiply both sides by 2/5 to get rid of that 5 halves power. So I get y squared equals 2/5 quantity x to the fourth plus c. And then finally, I'm just going to take the square root of both sides. So y is going to be equal to plus or minus 5 halves x to the fourth plus c. All right, and that's our general solution. And there's nothing else we can do with that. All right, just because it's gone through and there's no initial value for this one. Right? Another example, this one with an initial value. We have y prime of t equals e to the 3t minus 4y. Y at 1 is equal to 2. All right, so whenever we have y prime at t, we're just going to change that dy dt. Okay, so dependent variable in the numerator, independent in the denominator. And then we're also going to split up the right-hand side algebraically. So we're going to write this as e to the 3t, e to the minus 4y. All right, so this is a common trick that we use to be able to solve these types of differentials. All right, I'm going to multiply both sides by dt. So I get dy equals e to the 3t, e to the minus 4y dt. And then I'm going to divide both sides by this e to the minus 4y, so that way I can get all the y's to one side. So I get dy over e to the minus 4y equals e to the 3t dt. Another way to write this is to swing this up into the numerator since it has that negative exponent. So we could say that this becomes e to the minus 4y dy equals e to the 3t dt. And notice that now, or positive 4y, excuse me. And notice now that it's completely separated, all right? So now that we have all of the y terms on the left side and all of the t terms on the right side, I'm going to integrate, all right? And we're going to use the reverse of the chain rule for this. So instead of multiplying by 4, if we were to find the derivative, we would find the antiderivative. So this is going to be 1/4 e to the 4y. On the right-hand side, 1/3 e to the 3t plus c. Now, it does ask us to be able to solve for the initial value, or y of t is equal, or y at 1 is equal to 2. So that means when t equals 1, y equals 2. So let's just go ahead and substitute, and then we can solve for the independent or for the dependent variable. All right, so this is going to be 1/4 e to the 4 times 2 equals 1/3 e to the 3 times 1 plus c. Right? And then this just yields 1/4 e to the 8th minus 1/3 e cubed is equal to c. All right, so we're going to hold on to this because that's our constant of integration. And we're just going to substitute that back in right here, and then we can start solving. All right, so this is now going to be 1/4 e to the 4y is going to be equal to 1/3 e to the 3t plus 1/4 e to the 8th minus 1/3 e cubed. Right? Now, it does ask us to be able to solve for the independent variable. All right, so if we were to do that, we're going to multiply both sides by 4. So that's going to be 4/3 e to the 3t plus e to the 8th minus 4/3 e cubed. Then we're going to take the natural log of both sides. So we get 4y equals ln quantity 4/3 e to the 3t plus e to the 8th minus 4/3 e cubed. And then finally, we would divide by 4. So one way to write this answer would be 1/4 ln of 4/3 e to the 3t plus e to the 8th minus 4/3 e cubed. And then, of course, we remember that the 1/4 could also be written as the 1/4 power, right? So if I do that, then this just becomes ln of all that to the 1/4, all right? And that also means now that we could also rewrite this as the 4th root of everything that's inside the natural log, all right? So y would be equal to ln of the 4th root of 4/3 e to the 3t plus e to the 8th minus 4/3 e cubed. All right, so most of the time, somebody would probably accept like this answer if they were asking you to solve for the independent variable or for the dependent variable in terms of the independent variable. But just to be certain that you can see the multiple ways that this could be written, these are both viable solutions for this. All right, so we do have one more example that we're going to see in a subsequent video, but hopefully this gives you a good idea of the process for being able to solve these separable differentials.